He's a new media artist and creative technologist based in Toronto. His work has been described. It's basically the intersection of art, science, and technology. It's definitely up my alley. I can't wait to check this out. Utilizing computer programming and generative algorithms, he produces interactive and generative media that involve the relationship between geometry, pattern, light, and poetry. Ali, I cannot wait to see this. Everybody, please give him a warm welcome. Good to see you.
Hello. Thank you, FITC team. Appreciate what you're doing as a web knowledge event, and thanks Globacore for giving me the opportunity to present the project, a 3D experience that we developed for Google last year, and we worked on it for more than a year. And I'm very eager to share it with you, the experiences that I had and details and tweaks and some hacks that we did for that project. I'm gonna start a bit with my background and what I'm doing. As Jason mentioned, my name is Elifi. I'm a new media artist and creative technologist. Currently working with Globacore Interactive Technologies for more than 2 years. And mostly working on the web development and 3D environments, WebGL, 3JS, and all of these topics that I'm going to cover in a bit for those who are familiar with 3D elements and designing 3D experience environments for the web experiences, and those who are not familiar, and it's going to be just the opening door for them. So I'm a self-taught and self-trained new media artist. I use coding and programming to create an immersive environment, mostly before the pandemic time. And the pandemic brought me back to web development, the career that I started almost 20 years ago. Started with ASP.3 and ASP Classic, developing websites, and that was back in that time. It was pretty new, and I had no idea that I'm going back to web development probably 20 years later, this time with much more new technologies and 3D environments, and trying just to play around with all of the potentials and possibilities that web could provide for users to have different kind of interaction. The videos that you see are mostly what I've been doing for my practice, designing machines and programming boards, or having performances in Metaverse, and trying just to play with the tools that I have in hand. So with Globacore, since 2 years ago, most of the stuff that I've been doing was working on 3JS library. That's the WebGL renderer library for web development. This is one of the early projects that we did for called Reflection, which is a medical company based in the US. And the whole idea was scrolling down and going through the body and see how the therapy works. As you see, there are lots of animations and GLTF files and lights activated and deactivated based on the scrolling, and use the mouse position and playing around with the camera and renderers in different scenes. And this is another thing which was not that much for 3D stuff, but as an application which had a very special component for designing helmets for Acura, and the users could click and play around the 3D file and change the textures and participate in a contest that they had to be nominated for some prize, probably the helmet. And also the last part, which was again rendering real-time 3D files of the car, so the buyers and people interested in the design could play around with files in real time. And both of the experiences that you saw was responsive and mobile friendly. But what I'm going to talk about today is the experience that we had for the Google connected home products. We developed it for Google, I think about for Google Australia, for designing a space where all of these components was reactive and functional in 3D web environment and people could interact with those. So we work with some libraries that some of you might be familiar with. The whole platform was based on Next.js, which is a open source web development framework developed by Verso, and it's based on React as well. And what's happening is server render content happening as an incremental build. So the question that we had, the biggest challenge was just integration of 3D elements to the server-side rendering components of Next.js, which we found out we ended up using the library called React3 Fiber, which is a renderer for 3JS, and also the React3 Dry, which is some helpers that for making functional and making easier codes for activating the reaction between the 3D components and the UI that was happening in that experience. So this is the first screen that the users were supposed to interact for learning about the interaction, and some of these elements were baked and rendered in UI with CSS and real HTML components, and some of them were rendered as HTML on the canvas of 3JS. So basically what happens with 3JS, and especially in this project, is that there is one canvas rendered in the background, which is the 3D canvas, and all of those 3D elements and components are rendered in the backend. There is a new layer in front of it, which is rendering the images and UIs and parsing data and fetching data in real time with Harvey Norman shop, which is happening through an API callback to their shop directly for rendering for getting the latest available products and bundles and what they were selling. So the other challenge was rendering the elements and having the link to their bundles and to the real-time data of the retailer or the shop to present to the audience to be able to purchase. These are some screenshots from the environment. So basically we could see a tiny home from the bird eye view, and having different component, different rooms and different products, as you see they're outlined in the experience. And some of them had special functionality like the TV or like the Google Nest or the clock. So some functions was supposed to be activated for the products to be presented to the audience. And beside all of that, voice recognition and Google Assist voice recognition had to be implemented, that we use the same library. The most of those stuff were taken care of by from Globacore team, John Bolton, which was collaborating with us for that speech recognition library from Google to activating the orders to the 3D elements in the screen. Here I'm going to present a video about all the experience. So again, the experience was supposed to be reactive and responsive for mobile and tablet and desktop, which was the biggest key thing for that, which I'm going to follow, especially the challenges that we had for the mobile development and interaction. One of the, again, biggest thing was the loading time, because all of the 3D elements that you see in the environment was designed in Blender. And we had to optimize all of the files and lightings and shadows for having the fastest render possible in the back, on the canvas on the back, and having some hotspots so the users could click and go through, and having all of the active products from Google connected devices to the system outlined, and the fridge and some plugs and lights outline, which all of them had some, they could have some bundles or availability for the shop. So this part is all rendered with Next.js as a component on the front layer of after experience, so it has nothing to do with the background. And as you see, all of the prices, availability are fetched in real time, and also the pictures of the bundles, which is person fetched via the contentful for and updated with the producer and product manager for controlling the real time events. Here you see an example of voice recognition. So you could talk. I mean, you would activate your browsers or your phone's microphone to and mentioning to pronounce the words. And once you were talking, you used to activate, or you could just click on the message to have the interaction. So this one, which was one of the special interactions, was supposed to show the camera at the front door that we saw from the higher angle. And some of them had some very customized. It was actually showing the camera from this at the top of the door to the ground. And we have some of the products had their own very special customized functions to be activated. And yeah, as you see, this is again the interaction for the bundles. All of them were parsed with the shop, so via the shop's API. So if they had a bundle, the bundle would show up here. And for the UI and all of the content, we use Next.js for faster render and incremental build. And for the 3D, we use the React 3 fiber with some helpers, as you see. For those who know about 3JS, we didn't use any post-processing post-processing libraries, because it was affecting the performance a lot. And as you see, there are lots of details and lots of problems and the efforts that we had to take care of for in terms of optimizing the 3D files. As you see here for the TV, there was another remote control showing some images. This one was also from one of the customized functions that we had to implement for the experience. And yeah, going through the products for each room, again, seeing the bundles. And yeah, like here, there was a query for activating setting up the alarm or turning off the lights or turning on the lights. And as you see, the function turned the lights in the bedroom, and some other customized functions for the general. Each room was different. Like for instance, we had a special function for the printer that we couldn't really print the papers out. It was so yeah, lots of hassles and problems for printing papers in real time in Web 3D technologies, but we had to just implement the sound of printer for getting that to work. Yeah, and in terms of the responsiveness for the mobile, what we had to do was happening in two different fields, because some renderers and some shaders were not functioning perfectly for mobile renderers, mostly for Apple products. And for the phones, like we didn't have that much problem with the Android phones, but for the Apple, there was lots of limitations for voice queries, for interactions, and we had to do some hacks and fix for each of them. But this is the overall look at how it worked on the phone. So for the UI, everything was responsive, and also for in terms of for the 3D elements, we used to read the viewport and setting the camera field of view and angle and wideness of the camera, and setting some positions. So the camera component that we had in the code was kind of different for the mobile and for the desktop, because of the screen size and positioning and everything. And that one was reading at the time of the build, so changing the setting of the camera and renderer for handheld devices or mobile devices, and different for the desktop version. And this is how the project looked. And as you see, it is the hotspot that we had was another challenge for having pulsing, and we didn't want it to implement a lot of animations in React 3 Drive for for rendering real 3D elements. So the hotspots was replaced. They were replaced with CSS animations. So what you see on the hotspots are very lightweighted CSS animations rendered in the 3D canvas in 3JS. So in 3JS, we, beside having real 3D elements, we had some 2D elements and CSS elements that some of them had animation and some were just solid for covering some surfaces. And this was the solution that we ended up using for the hotspot and having them activated in both phones and desktop version, which we had a bit of problem on iPhone again for clicking on the CSS component rendered in 3D environment, but that one was resolved in the end. So I'm going to walk through the code itself. As you see, if you're familiar with Next.js development, there are lots of components for the rooms and 2D elements for CSS elements. For the rooms, we had a bigger container component for the rooms, and in each room we had the products imported as JSX files. So after rendering the GLTF files, we declared it as a JSX components inside the Next.js application for better rendering. So all of the elements in the rooms were separately imported as elements into the component section. And as you see, the API for parsing and fetching data with Harvey Norman. And this is the example of the main code for activating different, using the use state from 3JS and React components for activating different phases, selecting products. At the same time, we were clicking on the room and going through the products. The clients wanted to record all of those data for having them captured with the Google Analytics. We had to implement all of the clicks and everything. And store that data. And as you see for the rooms and everything for parsing and sending callbacks to the main application and reading, because we had lots of components over there. The camera thing, which was the craziest function of this project, it has some 100 lines of code for setting the camera position and changing based on the rooms that we're in and mobile and the desktop version. Here you see an example of a Google Nest product imported as JS6 into the bedroom component that we have. And as you see, with different other elements like lights and all of the activated, all imported as different components into the main application. And this is some samples for pushing the data. So again, because we wanted to show all of the interactions, each part of the room and each components, and clicking on each of the voice recognition orders or activating all of the functions were recorded and stored based on the user interaction that I don't have access to them, but I assume that there were some thousands of interactions for each room and all of the components and functions inside the experience. One of the special hacks that we had for the project in terms of the mobile development that it took me a long time, actually, not just for this project, but I really like to share that with developers, especially in 3D spaces that are developing something, and they would definitely end up this problem on phones, especially on iPhone. And that's where it happens, and you have the address bar and header here, and you want to experience that. You don't want to scroll, but by default, that header adds up to the height of your viewport. And if you're interacting, you're indirectly and unwantedly, you're just pulling the screen to top, and it really affects the interactions. And this is one of the hacks that I found, and it's been working great. Like getting the data from the device and reducing the height by a very tiny amount of person. So what happens is that less than 1 VH is reduced from bottom height of your screen, and everything looks solid. So it doesn't happen like scrolling, and by default your screen and application is totally locked and rigid at the viewport that you're interacting with. And this was one of the other biggest challenges that we had, because in terms of development for mobile devices, we ended up realizing that there's still some iPhone 7 and 8 used for these kind of project that we had no answer, because probably once they're developed, the iPhone 7 or older phones, they had no idea that 3D elements are going to be rendered in the screen. But again, with optimization in terms of the 3D files and type of the lights, shadows, and post-processing effects, like we try to reduce all of those and keep the performance as low as possible for most of the devices to be able to render the environment and have the interaction with the 3D environment. And because of the size of the screen on phones, usually the 3D environments are rendered better. So if you're running a 3JS application on a 4K screen with the best machine, you would probably realize that it's not rendering 60 frames per second. And as soon as you just reduce the size of the screen, you see how better things start to work. So this is one of the advantages of development for 3D environments for mobiles, but because of the size of the screen, it renders much more faster. And recently with the updates for Direct3 Fiber or the 3JS itself, most of the components and everything are intractable and responsive on the phones. So like a year ago, most of the components, we had some problems with the interaction of very different libraries for using the interaction with the 3D environment. But yeah, right now we don't have much problem because there's lots of improvements and developments and library updates. But in terms of the mobile development, this one for dealing with the height of the screen was one of the biggest challenges. So performance for designing and development of the 3D environments are always a big problem. And especially once you're designing something for big names and big brands, that they have lots of interaction and users to visit with different browsers and devices, is turning into a key point for that. I remember for the interactions that we had, like more than half of the viewers were using phones to interact with this experience. And that's when you're developing these kind of projects, like having Q&As and testing on different devices, on real devices, not just emulators, is something too much important, because you never had any idea that what happens on other phones and older phones, and especially like in different versions of, like, for instance, Safari for iOS, from like the different versions have different kind of interaction in terms of the address bar and the bottom, and just like a component could go wrong and affect the interaction that you can have with the 3D elements and its 3D experience. I hope that I covered the most of the topics that I wanted to talk about this project. The project is reachable on this long address or a QR code if you're interested. Hopefully it renders and works for all of you, rendering all of the elements, 3D elements, and not just promoting the Google products, but in terms of experiencing the 3D web experience here. And again, wanted to thank FITC and Globacore and all of you who attended to this talk, and hope you had some ideas and inspirations for developing your future projects.
Oh, that was awesome. One of the things that really is kind of amazing, like as these things have progressed, seeing 3D on the web over the years, the fact that seeing this stuff on real devices, um, seeing the way that it can respond. I mean, all of that stuff is really pretty incredible. One of the questions that we had, well, and first of all, I'll just say for everybody, thank you, Ali. That was really pretty spectacular work. Is this something that people can see? Is this project available to the public?
For this project, you mean, especially, or?
Yeah, yeah. Is that like part of the Google experience somewhere that people can check out?
Yes, on the link that I shared on this QR code here, they can see. So the experience
Oh,
itself
awesome.
was supposed. Yeah, this is a real project itself, but the project was presented in an iframe under main shop, which was another question for development because all we did as a independent project was presented in an iframe so they could interact and then they open it. So beside all of the data for the website, they were rendering something in 3D in an iframe on the back end. And again, in terms of the performance, that was a
Right.
challenge that we had. But yeah, if they want to access directly, this is the address that they can see the project.
Oh, that's awesome. And I know that people have posted that link again in the chat. So check that out if you get a chance. So speaking of performance, there's another great question from Shyam. Uh, is there a limitation for the number of objects that you can create, or is it more related to the complexity of those objects in terms of performance in that kind of?
I'd say there's no limits for the number of objects. So if you're familiar with the 3D world, like very complicated meshes and vertices, as much as you go with an object who has there are lots of meshes and vertices, it would affect. But but again, one of the challenges that we had was the files itself, like using the light. So what you see in the experience, it was one of the solutions that we came up. We baked the shadows and tech into the textures of the environment. So we almost removed any kind of lights and physical shadows happening and save like 50% of performance for the experience. These are the
Wow.
hacks that we have. So once you see there's a shadow, it's actually baked into the texture from our wonderful 3D artists and the solution that I think like Dave from Globacore came up with. But yeah, that's kind of the solution that you can add more objects, but instead of having a real 3D time. So in terms of 3JS, you have to have a camera, at least a renderer, some functions for recalling and changing, and lights and shadows are one of the heaviest part for in terms of performance for 3D environments and for the web as well. There's no limit in terms of numbers, but as you add more objects, you see
Hmm.
how the performance is reducing. So there are some
Right.
helpers that you can add on the production development phase that you can see how much the frame rate is reducing at that.
Right. So that's kind of related to, I mean, I think that sort of answers one of the other questions was really the challenge of optimizing these 3D assets for the widest range of users. Were there other things that I know you talked a bit about this, but in terms of like making it work well, as you were seeing the number of people looking at this on mobile devices, besides the sort of baking the shaders in, what were some of the other things that really kind of fundamentally changed for you about how to make these things and how to consider the experience for somebody on a smaller screen instead of a larger one?
Yeah, one of the other important thing was the size of the textures, because usually as you go bigger in the size of the texture, it looks cleaner and better. But the problem that we had was for the mobile phones, it really doesn't matter if it's 256 or 5012, 512, 512, and that was the other thing. So we could reduce the size of the textures in the 3D files to have it more optimized and lightweighted for the mobile. devices, and it wasn't that much affecting on the real desktop screen.
Mm-hmm.
But experiencing the opening the app on the like larger screens, even with a decent and cool, very powerful computers, was a bit of hassle in 4Ks and wider screens. But again, my experience for this project specifically was dealing with the objects and trying to keep them as light as possible. And also, there's a link for if you want to develop on
Mm-hmm.
React 3 Fiber, there's a link that you can drag and drop your GLTF file. So most of the objects that you see there are not OBJ, they're GLTF files. That's a component and file type that I believe it was developed for 3JS or by the 3JS community for having all of the textures and everything lightweighted, and you can add animations to those. So on that first experience that I showed, that was the reflection project, you can store animations inside the GLTF file and activating different animations based on the number and the key that you add to that file, and that really helps for adding animations and developing game or these kind of experiences. So I'd say like skip importing any kind of OBJ files or heavy files and try to optimize them and export them as
Mm-hmm.
GLTF. And if it's going to have any context of Next.js, just import it as a JSX component, which really makes a
Mm-hmm.
difference in terms of the performance.
And what about just the general like techniques for interaction? Was that something that you were thinking about differently with big screens and small, and in terms of how people would actually be interacting with the things that you were creating?
Well, here on this project, because we had a purpose and some products that had to be like presented, we didn't have that much flexibility. But in terms of the design from design team, which is not my jam for this project, but yeah, we had to add some hotspots that those hotspots, the visibility and the animation and how entering to the room. So we could have something like a normal games that people could zoom in and go in, but we really needed to limit the interactions by presenting the hotspot. So any kind of users would realize something flashing as
Mm-hmm.
that I should click on it and go to this room. And also we ended up limiting the rotation of the camera. So
Oh, okay.
basically it's a tool really worked, but we had to just limit the camera, and it was happening based on each room. We couldn't have a rigid limitation for the camera angle. So in each room, once you're clicking, the camera angle is limited for tilting and panning, so they cannot go anywhere they want. But as long as they see a hotspot and they click on it, and because it's a CSS file animation render, that it could be visible on the layers, and they can just click on it and navigate through different rooms, or with the menu that was provided as a hamburger menu on the side for the phones, and or as the real normal menu on the top for the desktop versions. But yeah, we tried to limit that because like uh majority of users could be easily lost in 3D world. It's not something that everybody's familiar with. So we think that all of our audiences or viewers for these projects are not gamers, and they have no idea about really real 3D world on a phone. So we needed to limit all of these interactions. Really.
So has that changed the way you think about other projects that you work on? So, I mean, things where you do have greater freedom, like VR environments and things like that. Has that kind of influenced the way you think about interaction there too?
Um, Honestly, I've been very interested in XR development for web technologies and running the hybrid projects. What I see at the audience right now, that's the same thing that happened with QR codes. Like before pandemic, we had QR codes for years, but no one really could know that and use that. And right now we have that, and yet the audience perception and interaction with these technologies, like in terms of, for instance, I remember I was developing a portal application as an AR application, which was supposed to be web-based application, not just locally host running. But I think yeah, that kind of freedom that I'm very interested in 3D web developments for my own projects is something that usually the users that really got into this technology and gaming can interact with. So most of the time with 3D environment, the normal average of users and normal users are kind of lost for navigating through the environment, and that's where the UX design for this 3D Web 3D projects becomes important, because like two icons can change everything for you. But I think I'm not the best resource or best person to talk about this in terms of the from the audience perspective and point of view. But yeah, most of the time, what I design and develop, yeah, I see that the users are lost, especially once it's like for the first project, once it's scrolling and people ended up they load a page that is a 3D elements and all they need to do is scrolling down. But because it's a bit of different kind of interaction, usually the normal users get lost, and yes, that's a controversial thing in 3D slash web project development.
So I know we're just about out of time, but I hope you'll be around in the chat a little bit. I know there's a lot of questions from people super impressed with the work that you showed and the potential that it has for really meaningful 3D interactions on the web. That was a great example. Thank you so much for sharing that.